Hi, I'm Chris Sauer. I'm President and CEO of Ocean Renewable Power Company. ORPC is a developer of tidal energy technology and projects. We got started in this business over 4 years ago now. The original idea was that if you could somehow take the energy in moving water in oceans and in rivers and convert that into electricity, even a small part of it, it would make a dramatic difference in the energy mix in the world. So we started in this journey looking initially at deep water ocean currents. As we developed our technology, we migrated more into tidal applications as well as river applications. We started out looking at technologies from around the world with the help of the U.S. Navy in evaluating what is the best way to convert moving water in the harsh ocean environment into electricity. And we've come up with a very unique arrangement. As you can see here on the chart, we have a turbine generator unit we call our TGU that has cross-flow turbines that are horizontally mounted on a single shaft with a generator in the middle. All of it is underwater, so the generator itself is an underwater permanent magnet generator. And one of the beauty parts of this is that no matter which way the water flows through these turbines, they always rotate in the same direction. So in a tidal environment, we don't have any repositioning of blades or equipment in order to continuously generate electricity. We have perfected the design to the point we now have specific designs for river applications. In river applications, we would essentially take the TGU, mount them on pilings or some other foundation in the river, have a series of those along the river, bring the power to shore where we would have our power electronics and our interconnection with the utility. In the case of tidal application in deep water ocean current applications, we have the ability to actually stack our TGUs into a configuration where we would have 4 high. Each of them has a generating capacity of 250 kilowatts in a 6-knot current. So our stack configuration we call a module, OCGen module. We've trademarked the name OCGen. It stands for Ocean Current Generation. So our OCGen modules will generate a peak capacity of 1 megawatt. They are slightly positively buoyant, so we're able to float them out to the site and then hold them down at the prescribed depth using a deep-sea mooring system. So we have no permanent structures affixed to the bottom, and we have the ability to place these in the water stream at whatever depth makes the most sense, considering things like shipping. You want to be below the ships, any recreational boating activities, and also considering where are the best current flows, at what depth are the strongest current flowing. So we've developed a technology that is very adaptable and we think has unique advantages over anything that other people are looking at that are developing technologies for these applications. Importantly, earlier this year we built our first turbine generator unit, and we tested it at our tidal energy site near Eastport, Maine, right on the border between Maine and Canada. By late April, we had absolutely demonstrated the technical feasibility of our TGU. We've continued testing. We've developed a tremendous testing capability using these Bay of Fundy tides, and have continued to improve the design. But we're very confident at this point that not only is this technically feasible, but by next summer we're going to be able to prove that they are commercially viable as well. Our hope is in 2010 to install our first river project, and in 2011 to install our first tidal energy project, which will in all likelihood be in Western Passage, one of our sites in Eastport, Maine. We also have a site in Anchorage, Alaska, in the Cook Inlet that we are developing. and our deployment there will probably be a year after our first deployment in Western Passage. So in summary, we got into this business because if you look at from a macro view, almost 3/4 of the Earth is covered with water. Almost 3/4 of the world's population lives within 200 miles, which is a very economic transmission distance from the oceans. So if you can somehow hook the two of them together, that we think that it will be create a significant impact for emission-free electricity and change the energy mix worldwide.